Hey friends, I hope you all are doing great. So friends, today we are going to talk about virtual private cloud, that is VPC, and this is going to be a very interesting theoretical lecture. So please stay tuned. Okay. Yeah. So first of all, let's talk about what is a VPC. So basically, a VPC stands for Virtual Private Cloud in AWS. So there will be, say different naming convention in case of other clouds, say on Azure or GCP, but in the AWS it is called as VPC. So why we are going to use this VPC? So basically, using this VPC, we can create a logically isolated section in the cloud where we can launch our resources such as say EC2 instance or RDS databases, etc. So you can consider a VPC, as your own data center in the cloud with the network and all the choice of your IP addresses, your subnets, everything, and that will be your VPC. And in that VPC, that is your isolated section or logical network, you can launch your all resources within that section. This is very simple. Okay. So by default, AWS provides us a default VPC, and when we will go ahead and create our own VPC, so that will be called as a custom VPC. So when we will see how we can create a VPC, then you will get to know. The default VPC is very user friendly. However, using custom VPC, we need to do some configuration before we can use it. Okay. And as I was mentioning, so we can create a custom VPC with the choice of IP address, subnets, and other components. So let's see which are the components. And subnet is nothing but say availability zone. So it's one a logical IP range. So that we will call as a subnet or availability zone. Okay. So what are the components of a VPC? So we have say different components of VPC called as say subnets. So as I was mentioning, so subnet will be, it spans an availability zone. So there will be never, it will never happen like a subnet will be spanning multiple availability zones. So one subnet will be responsible to cover one availability zone. So say one subnet, say for example, let's see 10.10.0.0.0/20. So this is, you can call as a one subnet, and this will be, can be work or in a particular availability zone. So there are two available subnets inside that. So one is public subnet, another will be private subnet. So public subnets, it's very simple, like it has got access to the internet. So we will ensure, so see the resources in the public subnet are able to access to the internet. And private subnet is something like you don't want to expose your resources to the internet. In that case, we will launch our resources inside the private subnet. Say for example databases or some other applications, due to security reason, if we don't want those to be allowed or to be exposed to the internet, then in that case we can launch them inside a private subnet. So next component is internet gateway, which is called as IGW or VPC, like VPG, virtual private gateway. So this IGW or VPG is responsible to provide an internet access. So in that case, see, with the IGW only, like internet gateway only, it's possible for us to access the resources which are there in the public subnet, and they can access to the internet. Then another entity that comes is route table. It's simply like it defines a route. So in the route table, we can provide the different directions, so, for the traffic. So like we will allow our internet gateway inside a route table, so that that particular subnet will be having access to internet. Then it comes network access control. You can call this as a NACL. So NACL will be as acting as a firewall, and this works. NACL works at the subnet level. And in the earlier sections, or like while the creation of the EC2 instance, you might have heard about the security group. So the security group is nothing but a firewall. It's again the firewall, but security group is, you can call it a section of NACL. So security group will act as an instance level, and subnet. Say we will launch our instances inside a subnet, and on the subnet level we will have network access control list. So friends, here you can see a typical architecture of a VPC, virtual private cloud. This particular VPC has various components like public subnet, private subnet, network access control list, route table, router, internet gateway, as well as virtual private gateway. Okay, so using using these components, VPC can be, this is a complete VPC using these components. You can, it's, it's not at all required like you should, it's not a rule like you should have two separate subnets like a public subnet or private subnet. You can either have only one subnet, it should be either a public subnet or a private subnet, or you can have a combination of both as per the architecture. So here you can see, first of all, the internet gateway. Using this we will get, the public subnet will get the access to the internet using internet gateway, and private VPG or virtual private gateway, with the help of this we can connect to the VPN and to the other VPCs using this one. Then we have router. So router will pass the traffic from particular gateway to the route tables. The route tables will define which are the, say, where the internet gateway is there, and it will basically, the rules of the, or traffic rules will be defined under the route table. From there traffic come to network access control list or NACL. NACL is kind of firewall. So using NACL you can allow or deny any particular traffic, say from a particular IP or from a particular region. So using a NACL you can do that. However, it's not possible using the security group. So security group, you can say a smaller subnet of NACL. So security group will act only at the instance level. However, NACL is being larger entity, and that acts at the entire subnet level. So this is a particular typical VPC, and we will learn, and while we will work on the demonstration part. Now these are some of the reserved IP addresses. So there's an entity called as Internet Assigned Numbers Authority, IANA. This is the organization that which is responsible to distribute the IP addresses to the world. So there are some of the IP addresses which are reserved for the private network. So which are those? Say for example, there are three subnets or subsets of the IP addresses. It's 10.0.0.0 to 10.255.255.255. This is one of the sub IP address which is reserved. Then another is 172.16.0.0 to 172.31.255.255. This is the another subnet or subset of IP addresses which are reserved by IANA. And the next subset, which is for which the IP addresses are reserved, is 192.168.0.0 to 192.168.255.255. So these are the IP addresses which are reserved by IANA. Now let's talk about VPC peering. So it's possible like there could be multiple of VPCs that are created. Say for example, you can create a VPC for finance department, another for say sales departments or marketing or production, like that. And using VPC peering, so peering is nothing but connection. So you can connect a VPC say in a one-to-one. Say for example, VPC A can be connected to VPC B or C or D or E, etc. And the resources, say if I connect my VPC A to VPC B, so resources will both the resources, say I have an EC2 instance in my VPC A and another EC2 instance in VPC B, and after VPC peering, this is a process once we have created a VPC. So using VPC peering, and when we connect to each other, so both those instances, say instance in the VPC A and instance in the VPC B, will talk to each other, and they will behave or act like those are in the same VPC. They won't think, or they won't behave like those are. So those will be acting as a local to each other. So that is the benefit of VPC peering. So here's some of the benefits of VPC peering. So it allows to connect one VPC to another VPC in the different account or even in the different regions. Say for example, you have a VPC A in, say for example, US East 1, that region, and I have another VPC B in say US or Asia South 1, or say, or for example Mumbai region. So using VPC peering, we can connect to these VPCs with each other. And the resources, as I was mentioning, will behave as being local to each other with the provision of VPC peering. Yep. However, there's one thing, like, we cannot connect to VPCs via third VPC. Say, for example, if I want my VPC-B to talk to VPC-C, so it should not pass through VPC-A. It's not allowed. So this is called as a transitive pairing, and transitive pairing is not allowed in the AWS or in the VPC. If you want to connect VPC-B to VPC-C, you should directly connect to each other using VPC pairing. It shouldn't go via VPC-A. So this is not allowed. So as I was mentioning, no transitive pairing is allowed. So friends, so let's summarize what we learned today. So a VPC stands for Virtual Private Cloud in AWS. Using VPC, we can create a logically isolated section where we can launch our resources like EC2 instance, RDS databases, and say, like lots of resources. So we can, it gives an added security to our resources, and we can customize. We can provide the IP address range whatever we wish, and we can do that. And this is a free service. Okay, VPC is a completely free service. It's not chargeable. But if say creating VPC, like say I have created my VPC, and inside that those resources, say I launch my EC2 instance, so those will be chargeable. But creation of a VPC is absolutely free. Okay, please make a note of this. Then we can create a custom VPC with a choice of IP address range, subnets, and other components which are associated with the VPC. So as per architecture, we can create or customize our VPC. So what are the main components of VPCs? So as we talked, so subnets, we have public subnet as private subnet. Public subnet has access to internet. However, private subnet is something we say if we don't want to allow our resources to act or to talk to internet. In that case, I will create a private subnet. So we have another component like internet gateway or private virtual private gateways, using which this internet gateway or VPGs will power. So that will be responsible for providing the internet to our public subnet. Then we have route table. It defines the routes. Like we will create routes, and in the route we will specify what is the internet gateway, and that can be done. So another thing is NACL, network access link, is network access control list is a kind of firewall, and firewall which acts as the security, which acts at the subnet level, and security groups is something it will act at the instance level. And one thing just note, like we can have only one internet gateway to be created on our VPC. So it's not possible like we can attach multiple internet gateway to the same VPC. We will get an error. So that is not possible. Okay. So friends, I hope you enjoyed, and I hope it was interesting session. You find it very interesting, and this was something new. And in the upcoming session, so I will create a new custom VPC, and I will show you, and we will try to launch some of the resources inside that custom VPC, and we will clarify our concept whatever we learned today. So thanks for watching, friends, and please like, share, and comment, and subscribe to my YouTube channel, Cloud with Mohsin. Okay, and if you have any queries, just type in the comment section. Okay, thank you. Bye bye.